Hello everyone, we are going to be solving today's daily Leetcode problem 2787, ways to express an integer as sum of powers. Before starting this problem, we shall have a small motivational quote. Passion and intuition should should guide your decision. It is equally important to balance them with logic and reason, right? Following your heart keeps you aligned with your true desires, but taking your brain along ensures you make smart, practical choices. Together will help you pursue dreams wisely, staying true to yourself while avoiding reckless risks. It's about harmonizing emotion and intellect for a fulfilling, sustainable path forward. Right? Everyone would have a desire that comes through their heart. Maybe they want to do something, but when you put your brain into it and put your useful thoughts into it, that's when it really becomes a fruitful result, right? Or your results will be achieved much more easier when you use your brain or think properly, right? So let's understand this problem. So this is a medium type problem. Given given two positive integers n and x, written the number of ways n can be expressed as the sum of xth power of a unique positive integer. In other words, uh, the number of set of unique integers n1 to nk, where n1 x uh, to n. Maybe I will show this out in an example. Maybe, for example, consider this example here, where 160 can be represented in this fashion, where all of these numbers are represented as power of 3, right? So that's a thing that has to be done. Uh, let's take the simple example again here in this example 1. So 3 3 power 2 and 1 power 2, this constitutes to 10. Anything with power 2 can be taken to represent it as the number n. So that's what this problem is expecting. Here 4 can be represented in two ways, that is 4 power 1 and also 3 power 1 plus 4. 3 power 1 plus 1 power 1. Okay. So now that we have understood this problem, let us think about how we can approach this solution, right? So So for this problem, there are many different approaches that can be taken to solve this problem. But we shall be using DP approach, where we shall be creating a DP array. If we remember, so we will be creating a DP array where we will initialize DP array such that it is of size n plus 1. N would be the number that we are looking to build with the power of sums. And before this, we will also pre-calculate all possible sums, all possible powers such that k power x is less than or equal to n, right? So we will create all the values such that power values such that it is less than or equal to n. And once we do that, we shall fill in the values for this DP array. And the way that we are going to do that is, let's say, uh, at any specific number, what is the number of ways to make sum? So we know that we shall be initializing this DP array with 0 as 1, because there is uh, only one way to make 0 and pick nothing. So for all the other set of DP values, we iterate uh, backwards such that we say, let's say a dp of s is equals to dp of s minus p. Like for example, let's say I will take a simple example here. So let's say we shall consider this specific case. Let's say uh, n is equals to 5 and all the pre-computed powers will be 1 to 4. These are all, this is the largest value such that it is less than 5. So now let's say we create our initial dp array starting at 1 0 0 and 0, and now we want to uh, let's say we want to do this operation such that for each power in powers array, and so these are the two for loops that we are going to be using in our code, where we are initializing with the maximum number that we want to build, and we are checking if this is greater than or equal to this sum, or this value is greater than or equal to power, then we decrement it, right? For example, let's say uh, a specific number, let's say in this case we are given a 10, and we our powers is equals to 1 to 1 to 4, right? And our number, let's say, is 5. So let's say we start out with the first loop. Let's say p is equals to 1, and all these values will go from 5. 5 will have a value 0, 4 will have 0, all the values will have 0, but 1 will be initialized with 1, and since the dp of 0 will be 1, because here as you see this is dp of 0, 0th index 1 2 3 4 5 4 5, right? So similarly we move on. Let's say we pick the value power 2, and our s values, that is, will go from 0. Dp values will be going like this: 1 1 1, and all the others will be 0 0. Similarly it keeps getting incremented, right? So once we reach the value 4, our dp array would look something like this, all the values being at 1. That means so why we update, so going backwards helps us find the previous set of values. Like for example, here here we are getting this dp array values such that what is the power value that adds up to make this sum, right? So that is what this dp array will carry forward. And finally, once we have that computed, the dp array computed, then we can return dp of n, or the specific number that we are looking for. Let's say uh, this will return the number of ways that we can form the number s minus. If we see, we will be calculating the value such that s minus p, right? So the s minus power that we are computing will give us the number of ways. So let me apply this solution and see if we can solve this. So we firstly need to pre-compute all the powers such that we capture all the powers which are less than the value n that we are looking to construct. So we add the breaking condition such that if the power is greater than n, then we do not push any more values to this powers array, right? Once we have that, we will create our DP array. So now to our main logic that we had. So we will go over each power and we will see how many ways we can make this power value add up to form the value n that we are looking for. So we will do that with a backward iteration. So we will have an s starting at n, and we will check if it is greater than p. P is the powers, and we will populate the DP array such that. Okay, so this should solve the problem. This is a crucial part to this solution. This DP computation logic is a crucial part to this solution. Take a moment and try understanding what we have here as per what I have shown in the drawing board. It would be easier to complete this solution. The time complexity of this solution would be O of n into m, where n is the number that we have here, and also m would be the number of powers, length of the powers array. So it would be uh, this would be the two set of for loops, right? And also the space complexity would be O of n because we have this DP array computed. Let me try submitting the solution. So this should be with respect to powers, right? Yeah, as you can see, the solution gets submitted. Hope you found this video helpful. Please do like and subscribe to my channel. Thank you.